Hello, welcome back to Learn Physics. In today's topic, it's a revision topic for class 10. So, in the last three chapters we finished, that is electricity, magnetic effects of electric current, and then reflection, light reflection and refraction. Those two chapters also, those chapters we finished. Now, only one more chapter is left out. So obviously source of energy also there, but it's not Paka theory portion it is, isn't it? If you are reading once, you can understand it very clearly. Okay, so no need of explanation at all, I guess. So today we are doing with human eye and the colorful world. Okay, so all these portions in detail we learned or I explained in the previous videos, and it is there in the description box. If you have any doubt, you can check into that. Okay, so here it's human eye and the colorful world. In that, first one is human eye. So the structure of eye and all, you know, it's like almost like a spherical in nature, isn't it? It will be like a spherical and it will be bulged little bit like this. And okay, so the outer part, this is called from here, that is cornea, retina is there, then cornea is there, and eyeball, iris, pupil. These are the major things. See, when light is incidenting on this cornea, what will happen? See, outer part, when light is entering at the outer part, what will happen? See, this will be here, a lens is here, crystal lens is there. That lens will be forming an image and will be falling that image on, and that image will be falling here on the retina. When it falls here on the retina, we can see the image. So how we are observing the image through our eye. Okay, so that one, first one is retina. Retina is backside, the light sensitive screen on the back side of the eye is called a retina. This is the light sensitive screen. Okay, that is called a retina. Okay, first, friend, what you are observing, that is cornea. Through cornea, light will be entering to our eye. Light is entering to our eye through the outer surface, that is called a cornea. Okay, light is entering through the eye through cornea, entering to the eye through the cornea. Next is eyeball. This eyeball is having a diameter of nearly 2.3 centimeters. The diameter of this eyeball is about 2.3 centimeters. And next is iris. Okay, that is, here we can see this. This is here the sides, you can see that muscular diaphragm. So that is called the iris. Iris will be controlling the size of the pupil. Okay, what is iris? Iris is a muscular diaphragm that controls the size of pupil. Okay, what is a pupil? See, black color thing. So that will be regulating and controlling the amount of light entering the eye. Okay, so the pupil will be controlling the amount of light entering through the eye. Okay, so this is outer covering, that is called the cornea, and next is eyeball, the whole thing, that is about 2.3 centimeters, and through iris. Iris is a dark muscular diaphragm which helps to control the size of the pupil. Okay, since it is controlling the size, the amount of light entering into the eye decreasing or increasing with the help of pupil. So pupil is regulating and controlling the light entering into the eye, and iris is the dark muscular diaphragm that controls the size of the pupil. So pupil itself, it can't do this increase or decrease of its size. So to help that, which is coming, iris. Okay, so you should usually children will be making mistake in these two. So please understand that iris is helping to control the size of pupil. Pupil will be controlling and managing the light entering into the eye. Okay, so clear. This is what about the eye. Okay, so here your crystalline lens is there. Okay, gel kind of that also size can be varied, that is its thickness can be increased or thickness can be decreased. Okay, so this eye lens will be forming an image and it will be falling on the retina. When it is falling on the retina, what will happen? It will be an inverted image. So this light which is falling on this retina will be identified by the light sensitive cells. Here we have light sensitive cells that will be attracting this, that will be absorbing this light which is falling on the retina. Okay, that will be converted into electric signals. Okay, electric signals, and through the optic nerve it will be going towards the brain. Through optic nerves, these images will be going to the brain as an inverted image. That inverted image will be identified by the brain and we are able to see the object clearly. Okay, so usually you can see when we are observing the image, we are observing it as an erect image, but actually what kind of image is forming on the retina? It will be an inverted image. Okay, when the light is falling on this cornea, what will happen? Retina, what will happen? It will be light sensitive cells will be absorbing that one and will be converting to electric signals, and those electric signals will be transmitted towards the brain through optic nerve, and brain will be identifying the image in the proper manner. Okay, so clear what are the functions of eye? So all the functions of all these cornea, iris, pupil. Okay, these are important. Okay, so next is power of accommodation. I told you here this eye lens can increase the focal length or decrease the focal length, isn't it? So that property, the power or ability of the eye lens to increase or decrease its focal length, okay, that is called it as power of accommodation. See, we can see the far object very clearly, we can see the near object also very clearly, isn't it? So what, see, there eye lens is adjusting its focal length, okay, either increasing the focal length or decreasing the focal length. It has the ability of the eye lens to increase the focal length or decrease the focal length, that is called a power of accommodation. The ability of the eye lens to increase the focal length or decrease the focal length, that is called a power of accommodation. Okay, here we are considering about the near point. Near point means which is the minimum distance, which what is the minimum distance required by the eye to see the object very clearly. See, if I am keeping it like this, I can see. If I am keeping it like this, I can't see it properly. Okay, so the minimum distance required by the eye lens to observe the object very clearly, that minimum distance is called a near point. Near point of a normal eye is 25 centimeter. Okay, next is far point, the maximum distance which we can see the object very clearly, that is called the far point. It is infinity. Infinity is the far point of a normal eye. Okay, so I will be getting many kind of diseases also, that eye diseases and all we will be studying. Along with that, another major disease which commonly occur is cataract due to aging. Okay, the eye lens will be cataract as a disease happening due to aging. See, while aging happens at that time, this cataract also may happen. Most of the people will be suffering with this cataract. Okay, it can be removed only through surgery. Okay, cataract can be removed only through surgery, and the reason is the eye lens will become milky and cloudy. So I told you it's like a gel kind of thing, transparent, isn't it? So it will be acting as a lens. So when the eye lens is becoming milky and cloudy, what will happen? They can't see the object very clearly. So that is called a cataract. This can be removed with the help of this surgery. Okay, clear this human eye and power of accommodation. So the defect of eye, here first we are learning about myopia. Myopia means near sight. Near sight means we can see only the near object. That is nearsightedness. That is called a myopia. We can see only near object. Far objects we can't see. That is myopia. So the far object means what will be the far point for them? For a myopic person, the far point will be, actual far point is infinity. So here for a myopic person, the far point is nearer than infinity. It won't be going till infinity. It will be very much nearer than infinity. That is the far point of a myopic person. For a myopic person, this near point will be 25 centimeter only, but the far point will be nearer than infinity. So here this is the this is the far O, which we are showing here. That will be the what is that? Far point of a myopic eye. Far point of a myopic eye is nearer than infinity. That is represented as O. Okay. So if from far away, maximum this much distance only, for a myopic person, they can view the objects very clearly, maximum up to this distance. But if from far objects, if the light ray is coming and falling on their eye, what will happen? An image will be forming in front of the retina. Okay, from here, from far infinite distance, if the light ray is falling and falling on their eye lens, what will happen? An image will be forming in front of the retina. So if it is falling on the retina, then only we can see the object clearly, isn't it? But it is not falling on the retina. Okay, so what we should do? We should use some corrective lens to take this image to the retina. How we can do that? With the help of a concave lens. So if we are using a concave lens, from far objects when light rays are coming, it will diverge. So those diverged lenses will be helping to divergent rays, right? So this divergent ray which is falling on the retina will helping this on this lens will help to make the image on the retina. Okay, clear? So this is the far point. This is how we will be finding out we will be using the corrective lens. So these three diagrams are very important. That is for a myopic eye. From far object, where is the position of far object? Far point. Okay, if from infinity the light ray is coming, where it will fall? What we should do to correct that? We should use a concave lens we should use. Okay, now what is the reason for this myopic eye? Okay, myopia. What are the reasons? First one is excessive curvature of the eye lens. Eye lens will be, curvature will be more. Okay, curvature will be more for eye lens. And the eyeball, elongation of the eyeball. Okay, elongation of the eyeball and excessive curvature of the eye lens. These are the reasons for the myopic eye. How we can correct that? We can use a concave lens. So for a myopic eye, nearsightedness, they can see only nearby object. And far point will be nearer than infinity. And these three diagrams and the reasons for that: excessive curvature of eye lens and the elongation of the eyeball, and how we can correct that using a concave lens. Now we are going to study about the far sightedness. Okay, so that is hypermetropia. we are going to study about hypermetropia. So next is hypermetropia. Hypermetropia means it is far sight. Far-sightedness is called hypermetropia. So here from the name itself we can understand it is long distance only vision is there. Far sight. Far distance we can observe the object very clearly. So near sight will be having an issue. Okay, so for a near point we know for a normal eye it is about 25 centimeter. So here near point will be more than 25 centimeter. Okay, near point will be more away from the actual near point. Okay, so here this is the position of normal near point in the case of a hypermetropic person. Instead of the normal near point, this will be more far away. So from the actual near point when the light ray is falling, that is from the actual near point means by 25 centimeter, if the light ray is falling, what will happen? It will be forming an image behind the mirror or behind the retina. It will be forming an image behind the retina. Okay, so whether we will be able to see the image clearly? No. Why? Because it is forming behind the retina. Now what we should do? We can use the corrective lens of convex lens. Okay, correction can be made with the help of convex lens. If we are taking a convex lens from the near point also, we can take the image and you can convert the image to the retina. Okay, so this is how we will be correcting the hypermetropia. And what are the reasons for this one? It is focal length is too long. Focal length of the eye lens will be too long and the eyeball has become very small. That is there in myopia we learned everything excessive curvature, isn't it? Here focal length became too long and eyeball has become too small. That is the reason for hypermetropia. Okay, now one more is left out, that is presbyopia. Presbyopia means it is including both myopia and hypermetropia. That means myopic eye means we know far object we can see, we can't see clearly, and the hypermetropia means near object we can't see clearly, isn't it? So these two defects together, that is even far or near object, they can't see clearly. Not because of cataract. Cataract we already told everything will be blurred for them. But in the case of hypermetropia, even far object or near object they can't see properly. That is another defect called a presbyopia. Okay, so how we can use? In the same glass itself they will be using convex and concave lens. Okay, one side will be convex and the other side will be concave in the case of presbyopia. Okay, presbyopia has myopic eye, that is near point and far point. Both won't be at the far point, both won't be at the normal position. Okay, so they will be using a corrective lens here. Lower part they will be using a convex lens and the upper part a concave lens will be used. Okay, this is how. So lower part a convex lens, that is for covering, convex lenses for our hypermetropia and concave lenses for our myopia. Okay, clear? So this is how we will be correcting the eye defects. Clear for you? Next is refraction through a prism. Refraction through a prism. Okay, how the refraction will be happening in the case of prism. Okay, so here see, this is a prism. Okay, if light ray is incidenting over here, it will be getting refracted and it is again refracted. This ray is called incident ray and this is called a emergent ray. Okay, the angle between the two lateral sides, this angle is called the angle of the prism. Angle between the two lateral sides, this is called the angle of the prism. Angle of prism. See, and the angle between incident ray and the emergent ray, that is called a angle of deviation. Angle of deviation. Angle between the emergent ray and the incident ray, that is called a angle of deviation. Okay, the angle between the two lateral sides is called the angle of prism, and the angle between incident ray and emergent ray is called the angle of deviation. And when the light ray is incidenting, white light is incidenting on the prism, what will happen? It will split into its constituent colors. That is, white light will be splitting it into vizier, that colors. In that, red will be the least deviated one and violet will be the most deviated one. Okay, violet will be getting more deviation and red will be the least deviation. Why? Because red is having wavelength more. If wavelength is more, velocity will be more. Okay, V is equal to nu lambda. Okay, this is the formula. So wavelength increases, velocity also will be increases. Wavelength decreases, since it has less wavelength, velocity also will be less. Okay, since each color, the wavelength is different for each color, so it will be having different velocities in this medium. Okay, clear for you? This is the cause of, so it is splitting it into its constituent colors. This phenomenon is called as dispersion. Dispersion is the phenomenon of splitting of white light into its constituent colors. This phenomenon is called as dispersion. Dispersion is the phenomenon of splitting of white light into its constituent colors. Okay, so if we are using a prism like this, what will happen? It will split into its constituent colors, isn't it? So, and if I am using another prism in this manner, what will happen? It will again combine into white light. Okay, so there's two white lights. Say two prisms. If I am using that, I will be getting a white light back. Okay, so clear. So this is about the refraction of the prism. Okay, clear? So I hope all these topics are clear for you. This will be this is under a quick revision. If you want to revise everything once more, you can utilize this video. Okay, and the next, atmospheric refraction and scattering of light, with that I will be coming in the next video. Next Wednesday, as usual, you can expect this next video in Wednesday. Okay, because of the personal issues, I couldn't give that this video yesterday. So the next video will be on Wednesday only. Okay, so and January onwards we'll be starting the new year, and the new year I'll be starting the new set of question papers. We will start with the question papers. Okay, so I hope it is clear for you, and if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.